These are our Scara robots CAD parts from CAD program, and in this program we are in the assembling part. So we will show you some bearings and their purposes. Okay, let's start. We use two type of bearings. One of them is deep ball bearing, and the other one is thrust ball bearing. Deep ball bearing was used for the smooth movement between axes and between links. The other thrust ball bearing, this one, was used for prevent the bending stresses when the gripper grab some object. It causes some bending. So this thrust ball bearing, thanks to their component types and their naturality, it prevent the bending. We used 3 of them, and 1 of them here and 2 of them here and here. We used 3 ball bearing, 1 of them here and the other ones here and here.
Hello, we are Onur Ali Elmas and Ahmet Şimşek. Today we will introduce our final project. This is a Scara robot which has a 4 degrees of freedom, comes from the 4 motors. 3 of them are step motors and 1 of them is servo motor. The first step motor is Z-axis step motor. It can transfer the base movement for the up and down, and this motor is for the second link motor, second link movement, and it transfers the movement from here to here by using pulley, these 2 pulley. After this point, I will say this step motor Z-axis motor, and this one is Y-axis motor, and the last step motor is this one. This is for the first link. The same mechanism was used for the transfer the movement power, and after this point I will say it X-axis motor, step motor, and the last motor is servo motor, which we used. It is for the gripping mechanism, and so we use this bolt for the linear actuator mechanism, and the other ones, other whole body was printed from 3D printer, and the material is PLA filament. So we use this linear bearings for better smooth movement and for better power transform. So we used these bearings for the same purposes, and for this movement we use this bolts without teeth, and that one. For controlling the robot, we have some electronic components, which first one is Arduino Uno. This is a typical microcontroller for our projects, and this is CNC shield for better accuracy and better control the step motors. And also we have step motors, we need to use these drivers, which these are A4988 step motor drivers. This is 3 of them. And also we have a 12 volt 4 amp battery power supply, and this one's all the whole electronic components. Okay, let me try to assemble them for the connections. The drivers is all same, so just put them on these three axes. The first one is X, second one is Y, and third one Z. The X axis I put them here, and second one I put them here, and third one I put them here. Also after that point I need to use these cables for connection drivers. It doesn't matter which direction is true or false. When I try to this change its direction, just it's change step motors revolution direction. And for prevent the electronic components fuel extend their amp or volt, we need to use this jumper cable for these two pin. I put them here. Okay, now I directly assemble it to Arduino Uno. And then the power connection like this and this. So lastly, the servo motor cables comes from here, and this links has a this covers. So let's like this cable comes from here to here like this for better and so this red one is plus, the black one minus, and this is yellow one is signal. So I put them here, and this is the whole electronic connection and assembly.
Hello, it is our code review. This is our code that we use in our Scara robot. Firstly, we included the Excel stepper and servo libraries. These libraries are necessary for controlling our stepper and servo motors. Here we defined our pins and we define our servo. In the setup loop, we define a serial port screen, and in the loop we define an char to read the input when we type a R letter in the serial port screen, and if it recognizes R letter, it will perform a motion and before the motion the steppers are set to maximum speed and acceleration values. And then we define the pins of the servo motor and set our current positions to 0. Then first of all we open the gripper and move the stepper tree. Stepper tree is our Z-axis stepper motor. Stepper 1 is our stepper motor that give motion to the first link,
and the second stepper is the stepper motor that gives motion to the second link. The motion is a prescribed motion that we defined before, and we set all the motions to perform that prescribed motion. Here's the definitions of each movement. We describe it, and when all the processes are done, it says duty is completed, and it is ready for another R input to perform the same motion again. And it is a simple code, and it performed really good. And this is it. Thank you for listening.